Good morning. We're going to be investigating laboratory experiment number 3, the identification of the unknown from the second lab. This would be the material that you claimed from the dichloromethane. Most of you have it in the desiccator at this point. And what we're going to do is first is make it better. In other words, we're going to try to clean it up, get any remaining aspirin or sugar that might have remained with this material and any other impurities that would be in there with it. Get those away from it, and then we will do a technique called recrystallization. And then what we'll do is to make a decision upon which of the two unknowns it is by using melting point apparatus. So it's in essence the recrystallization is probably one of the most important techniques in all of organic chemistry for non-volatile organic solids. So if something's non-volatile, it won't just evaporate away on its own solid. What you do is you take material to be purified and you put it in an appropriate hot solvent. As the solvent cools, then the solution becomes saturated with the crystals and they precipitate out. And we can get rid of, we hope, if you allow the crystal to form on its own, it has a tendency to only take into the crystal the materials that are good that it wants. Now, how do you pick a solvent? These are all going to be final exam and quiz questions. I mean, about picking the solvent and this whole technique. We will do this thing over and over and over again. If you stay around for next semester, I mean, it's just our go-to method. But what you have to have a situation where the substance that you have is very soluble in the hot solvent, but not dissolve at low temperature in that solvent. And amazingly, this happens with many solvents and many chemicals. So obviously here in the beginning, we'll pick the solvent for you. Future things, you kind of have to make a decision on the solvent. And so a lot of times you have to take some of your material and see if it dissolves in a small amount of cold solvent. So you also want a solvent that either dissolves impurities readily or not at all. So sometimes it's better if if your impurities won't dissolve in the solvent, then they'll just be floating on the top, and you can gravity filter those off. Um, so a lot of times, that's some part we usually don't get into a lot. You don't want it to react with the solute, obviously, because if your solute is soluble or reacts with it, then you lose all your material. And you'd like for it to be non-flammable, inexpensive, and very volatile, so you can get rid of it easily. Um, Bad part is typically volatile and non and flammable go together. So you can't get too much, obviously. So the technique usually is, and I'm going to give you a link to a video. The technique is get some solvent hot, and then pour a little bit in, not very much, in on your solute, and then put that beaker onto the hot plate and swirl. If it doesn't dissolve, add a little more hot solvent. Every time you're going to have to let that hot solvent get to boiling again. With the theory being when you add just the right amount and it's boiling, all of the solute dissolves. So this is a trial and error slow technique. You don't want to go too slowly, or you have a tendency for your material to boil up on the sides of the beaker, and that doesn't seem to work very well. Decolorize the solution. Early on, we're not going to be doing the decolorizing. We can use what's called a Norit, usually is the one we use, Norit, and it is a decolorizing carbon. It will suck any impurities that are providing color to, if you've got a white or a colorless crystal, you don't want it to be red or brown or something like that. So you put a little bit of that in, and then you gravity filter it. If there's anything hanging around on top, floating around, you're going to take, while it's still hot, pour it through a fast filter paper and catch anything that, any floaties. You should never filter using a Buchner funnel when you do this. The crystals will develop in the Buchner funnel, and you'll probably lose your material. Everybody always says, why don't we just go really fast and Buchner funnel it? And then all your stuff will stay there. Most important step is probably step 5, and that is, then you just take your nice clean beaker with the nice clean crystals that are still dissolved in the hot solvent, and you just let it sit there. I mean, you don't bother it. Everybody's in a hurry to go home, so they want to rush this step, and then they wonder why they get really bad results at this step. So this is just kind of a catch up, clean up, let the stuff just sit there. And typically what you're going to do is, the slower the cooling process, the less chance you trap the impurities, and the better the results you'll get. Now, sometimes when it's cooling down, you'll find out you don't have any crystals. And you can scratch the inside walls of your vessel with a glass stirring rod. Glass will scratch glass. And it'll kick up a little piece of glass, which your crystals will form around it. Or find another classmate who has crystals. Steal a crystal from them. Throw it in. See if you can use that to start the nucleation. Now, to improve your results, to improve your yield, after you let it get to room temperature and cool, you can take the entire beaker and put it into an ice water bath. That will dramatically reduce the temperature. And sometimes at that temperature, you need to get it that low before your crystals will form. People want to hurry this process and do that immediately. When you do it fast from the beginning, you risk the chance of having very dirty crystals still. Now you take a Buchner funnel and weigh your filter paper and pour it on there and filter it, and then take a little bit of the cold recrystallization solvent. So in another beaker in an ice bath, have some cold solvent ready, and you just want to wash the crystals off with the cold solvent. So if anything's left on the crystals after you've pulled them through the Buchner funnel, this will do that. And you can also use a little cold solvent to get some out of the container you were recrystallizing in if they all didn't go in. Then you got to dry the crystals. Once crystals get dry, you can put them into a melting point machine. I'll show you the melting point machine. There, we have this one, the Melt Temp. And we also have this one, the Vernier. And we do have a few stray old ones. These are all modern machines. I couldn't even find a picture of our old units anymore. But all of them work on the same principle. And that principle is there's a little heating core down in where you're going to place your little capillary tubes. And here's an example of one that you can see kind of close up. Here's these capillary tubes. They stick down and they touch the heating element, and you just want a tiny little bit in there. If you'll notice, here's this great big capillary tube, and we're just putting that little bitty bit down here. There's usually a magnifying glass so you can see it easier. And then there's some kind of controls. The melt temp, there is a thermometer sticking out of the top that you'll have to read. The Vernier ones are digital, so you can read it digitally. And we'll have to go to the second part of the video here, and we'll pick it up here in just a second.